Hi guys, can you hear me? So, okay, it's starting to come in. So I'm not sure if you was hearing me all the time or if you can hear me now, but okay. So yeah, I was just saying to everybody to let me know if you guys are ready to get into the second one. Send your feedback. And what I was saying is that, in terms of content, right? Measurement has the least amount of content because it's just a bunch of formulas you have to use to find information. The challenge that comes with measurement is that they give you these questions that are based on real life objects. So it really comes down to making sure you understand the picture, you understand the object, and you understand what they're asking you to do with the object. So it's always the area, perimeter, surface area, volume. It's just really those two things. But the challenge comes with conversion because they're going to give you the volume in one measurement, but then ask you to find something from it in another measurement. So you have to be mentally prepared and understand how to move from one measurement to another. That includes millimeters, centimeters, meters, kilometers, grams, kilograms, liters to centimeters cube, and even time, and even stuff like speed and stuff like that. Those are the type of questions that come. So before we get into the actual questions, we're going to review the basic formulas of certain shapes. We did this already, so I'm just going to run through it as fast as possible. And unless there's a question that you need me to, or a formula you want me to explain in depth, you would indicate by saying something. But I think I'll send out this handout. Did I send you guys this handout? With all the formulas, you could probably print it out if you need to. This is something good to have printed out, to be honest. So let's jump into it now. All right, so just as soon as we finish this session, just remind me to send it to you via WhatsApp, because I would have to convert it to PDF, download it from this software and download it before I could send it. So you would have to remind me. So during the break for the next session, I could do that. All right, so let's get started. First thing first, we must be able to identify shapes and understand what their properties are. So we're going to just get into the basic stuff. Where's the tea? You're not ready? What happened? Yeah, you could eat and listen. You ain't got to. You could eat and listen, eat and watch. You could eat while you're watching because you're not gonna need to do anything. I'm just gonna go through everything. So you just gotta watch. I am sending this document after, so you could always revise or write down anything or have it with you if you need it. Okay. So all those who are here, I will send it to you. You would have to let me know. All right, let's go. So we're gonna start off with area and perimeter. That's the most basic two concepts. After area and perimeter, we have volume and surface area. And then we have conversion from different units to different units, which include time in hours, time in minutes, moving from one place at one time, ending up at another place at another time. You should be able to calculate how long it took. Another type of measurement question that comes is speed and velocity. So somebody took this amount of time to get to this distance. What is the speed? All of that we're going to look at. So let's go. Easy to identify as a square. We have area and perimeter. So if the length of one side is the same, you don't have to add L plus L plus L. You just multiply L by 4 because it's 4 sides and all of them are alike. Similarly, the area, generally for any quadrilateral, which would be rectangle or square, the formula is length times width. But for a square, the length is the width. So that's how we get length times the length, which is L square. So if they give you the area of a square and they ask for one side, what do? You square root it, right? So one side is the square root of it. So if I tell you the area of a square is 25 meters, guys, what's the length of one side? 5, because the square root of 25 is 5. Simple stuff. Next thing we have is a rectangle. One of the things we know is that the opposite sides are the same. So that's why you would have 2L plus 2B, which is the same thing as factor out the 2L plus B, right? Same thing here, length times width. Here they use B for base or something, I don't know, but it's the same thing as length times width. Easy formulas that do not come on the exam. Next, we have a parallelogram. Now, the truth is, a square and a rectangle is a parallelogram by definition. A parallelogram is where the opposite sides is a quadrilateral, where the opposite sides are parallel. And if you see the square, the opposite sides parallel, rectangle, opposite sides parallel. So they gave us two formulas. Now, the truth is, you're going to need them because sometimes in geometry, even though we in measurement, sometimes in geometry that is asked us to find the area of a shape using the angle. So please make a mental note of that. But generally, how do we find the area of a parallelogram? It's really length times width, or height. So you see length would be this, how long it is, by the vertical perpendicular height. And what indicates that it is a perpendicular height? This box, which represents 90 degrees. All right, so that's an easy one. B times H, base times height. Now, the area could also be used as the two sides, A times B, but you have to find sine theta, where theta is the angles between the two sides. Okay? This is something good to keep in your mind. Perimeter, easy, add up the sides. That's B plus A plus A. All right. Here we have a rhombus. What is the only difference with a rhombus? Now, even though this diagram doesn't look correct, these two sides are equal. So we see here is the same thing, base times height. Height, that's the area. And you know how to find the perimeter. The perimeter would be 4 times B because B and A is the same thing. All right, everybody good to go with these so far? Because again, these formulas do not come on your exam paper. You have to memorize it, right? So everybody good with these? All right, now this triangle formula is also very important. There are 3 formulas. One, the basic one that we know, half base times height. Easy stuff. But I'm going to tell you, why you think it's important to know these here? We have a whole topic called trigonometry, and trigonometry is only about triangles. So it is important to know all of the formulas in relation to the area of a triangle. Now, luckily for you, this is also on your exam. So this on your formula sheet. You don't need to memorize this. So you're good to go with this. All three of them are on the formula sheet, but you have to know the difference between them. The first one, you must have the height. That's why you have half base times height. Suppose you don't have the height. Suppose you only have the length of all sides. Can you find the area? Yes, using this formula here, which you can find in your formula sheet. Sorry, not this down here. This is the perimeter. So you just go to your formula sheet. Once you realize you got all three sides, you know it's possible to find the area using a formula, and this is the formula. You just got to calculate S. Here you see the formula uses S, and what is A? A, B, and C are the three different sides. How do you calculate S? The perimeter divided by 2. Again, all of this is in your formula sheet. So if you don't remember, you just look at it and you follow. Everybody understand what I'm showing you here with this second formula? Okay, I'll repeat. The first formula used half base times height. So once you have the base and the height of a triangle, that's the formula you use. Suppose you don't have the height, but you have all three sides, the length of all three sides of the triangle. So you have A, B, and C, the distance of all the sides. You have to use the second formula, which is the square root of S times S minus A times S minus B times S minus C. These are found on your formula sheet. So here they explain to you how to find S. So you can't use this because you need S. So you have to find S first. How do you find S? Perimeter. What does perimeter mean? Add up all the sides. So when you add up all the sides, you divide by 2 and the answer is S. Once you find S, what do? You substitute it into the formula. Do we know what A, B, and C represents again? A, B, and C represent the lengths of the side. Now, everybody should be able to substitute in it. Everybody should be able to substitute in a formula at this point. So anybody could give you any formula, give you the different elements of the formula, and you should be able to substitute and calculate. So I need everybody to confirm with me now. Are you able to substitute and then solve it on your own? I'm watching. If it's a no, say no. So let me come to the side and show you something. Suppose I say we got formula M is equal to the square root of A squared plus B plus 2C. And I tell you A is equal to 2, B is equal to 3, C is equal to 4. Oh, I seen something pop up on my screen right now, like a box. Okay, that was the first video that was converted. So after this session, I have to upload it to YouTube so it's available for you. Okay? Yeah, so the first video from the first session was converted. All right, so there we go. Substitution means we replace the letter or the variable with the actual value. So if I tell you solve M, find the answer for M, what you got to do? Replace A with what? So you write back M is equal to the square root. So it's going to be 2 square plus what? Plus 3. What? Plus what? They're saying 2 times 4, 2C and 2 times 4. Everybody with me? And we know that the last thing that you do is the square root. So what is going to give you? 4 plus 3 plus 8. So what we're going to end up with 7 plus 8 is 15. The square root of 15, and you know you're going to get your answer when you do that. That's what substitution means. So when you have this formula, if I tell you A is 2 and 3 and 4, before you plug it in, you got to calculate your S. So how do you find S? You add 2 plus 3 plus 4. What is that? 10? Yeah, no, that's 9. So it's going to be 9 divided by 2. So S is equal to 9 divided by 2, which is 4.5. So You're going to plug in, everywhere you see S, you plug in what? 4.5. Everywhere you see A, you plug in 2. Everywhere you see B, you plug in 3. And you just work it out until you get your final answer. Everybody with me? This is a big part of algebra, by the way. So what I recommend is that you go and look at the summary notes videos on algebra, because you have to make sure your algebra skills are legit and tight. All right, next shape we see here is a kite. Diagonal 1, and we should know what a diagonal is when you connect two opposite points of a quadrilateral, right? So we have two diagonals here. So what is the formula? This does not come on your formula sheet. So you need to know this just in case. Half D1, D2, okay? Next, shape trapezium. This is a very popular question. Very, very popular question. You must memorize. From which one? This one? Remember, I'm going to send out this document, you know. Do not try to write down anything right now. We don't have the time for that. So you just have to follow and make sure you understand. And then I'm going to send everybody the actual document so you could copy down or print it if you need to, okay? Everybody understand? For now, we're just going through it because we have to go through all of the formulas. All right, so let me keep it moving. So as we see here, this is a very popular shape for CXC, very popular. This formula does not come on your formula sheet, so you have to memorize it. This is the trapezium, which is a type of quadrilateral. And as we see here, we have half A plus B times H. What is A and B? A and B are the lengths of your parallel lines, and this is your parallel lines. So you add them, you half it, and the answer you multiply by H, okay? H is always the perpendicular height. Please remember, if they put 3 here, 3 is not the height. If they put 4 over here, 4 is not the height. You realize it's slanting. The height is the perpendicular distance, which is represented by a 90 degrees. All right. Now, you know the truth is, you know the circle, I'm going to be honest, when I see circle, I just feel stressed. You know, I just be like, oh my God, pi. And you know, they don't tell you what pi is. What is pi, people? What is pi? Yeah, I'm going to tell you the truth. It's 2 types of pi. You could use 22 over 7 or 3.142. Sometimes CXCers tell you which one, sometimes they do not. Be prepared for them not to tell you. No, these are the 2 things people is confused all the time. These 2 formulas. I think this come on the exam paper, thank God. It does. But still, it's better to remember because you don't want to waste time every minute flipping back. You only flip back if you're not confident and you need to back check, okay? So formula pi r square, where we know r is the radius. If given the diameter, how do we find the radius, people? If they tell us the diameter, how do you find the radius? You gotta divide by 2 because the diameter is equal to 2 times the radius. So if you want to find the diameter from the radius, you multiply by 2. If you want to find the radius from the diameter, you divide by 2. Don't ever forget that. Please, 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 please. So just what we have here, perimeter is equal to 2 pi r, which is different from pi r square. This has another formula because 2 radius is what? In a diameter. So the second formula is pi d. This does not come on the exam, on the formula sheet. So 2 formulas for circumference, which is the same thing as the perimeter. 2 pi r or pi d. So that's the first page. If you got it, say got it. Everybody okay with everything we talk about on the first page? These are our basic shapes. And remember, it is possible to create other shapes with a combination of these shapes. So we must know these very well. All right, so we're moving on to page 2. You see, we went through all of this already, but this is just us recapping. I'm not going to be spending a lot of time on this. So 2 things. No, this does not come on your formula sheet. Does it? Does it not? I had it here, you know, a CXC formula sheet. I think it does. I think these things does. I don't think this one over here does, but this one does. The sector. So just to keep in mind, sector is the slice, the whole slice. This is what you call a slice, and this is the formula. You use a fraction. Why is it a fraction? Because it's a portion. Isn't it a fraction of the circle? So the angle that you're using would be the numerator. 360 would be the denominator, because why? The entire circle adds up to 360. And so what are you finding? You're finding a fraction of the overall area. Everybody see that? It's common sense. Everybody with me? Same thing with the arc. What do we call an arc? The arc is a portion of the circumference. So if I just want this section here of the arc, instead of using the area, I would use a fraction of the circumference. And instead of using 2 pi r, I could use what? Pi d. So fraction of the area, fraction of the circumference. Now, if they want you to find the perimeter, you know, that's the distance all the way around. You know, if this is the radius, what is over here as well? The radius. Everybody see that? So you find the arc, and then you add 2 radius to find the overall shape, perimeter. Please make sure you understand these things. Moving along. Now, if you look at the sector, inside the segment now, what is the difference between a sector and a segment? The sector is created by 2 radii. The segment is created by what? What is this line called? What do we call that line there? Excellent, the chord. These are things we need to remember, right? So you realize the chord creates a major segment and a minor segment. How do we find the area of that? You realize the segment is a part of the sector. So what they're telling you to do, step 1, find the area of the entire sector. What shape is this inside here? Then a triangle. So you find the area of the triangle, and based on the formulas we did before, to be honest, that's the only one I forgot to talk about. So let me go back. We spoke about 2, we forget about the last one. The second formula here, let me highlight it in green. These 2 is the same thing. Half AB, which is the sides, and the angle in between it, sine C. This is very similar to the parallelogram. Yeah, realize to find the area? AB sine C, sine theta, sorry. AB sine theta, which is the same thing as the angle in between. So that's another formula, okay? That comes very handy when you have 2 sides and the angle between the 2 sides. So area of a triangle, this is the same formula right there. Half r square. And why is it r square? Because what is the length of the 2 sides that the angle is in between? In the 2 radii. So everybody see that? The relationship is the same thing. Half AB sine theta. But AB are r times r, which is r square. So you want to find this area, you find the whole thing, and then you subtract the formula, the area for the triangle. So this part here is really the important part. This has come not often, but I just want to make sure you know what to do in case it comes. All right, so that's it for the circle. Nothing else gonna come for the circle when it comes to measurements, guys. Is that you're finding the area of this whole circle or an area of a piece of a circle, and there's only 2 pieces you could find. You're either finding the sector or the segment, and you don't know based on this how to find it. Everybody good to go? We're gonna look at some examples of it, so don't panic. I have such a headache. So only 1 person got it. We got 17 people here. Let's go. All right. Keep it in mind, there will be no question that comes that look like this. It will never. Keep in mind that these are just your foundational steps because the images that you get will include these shapes and not be the shape alone. All right, so let's get into our 3D shapes. Volume. A lot of persons express that they struggle with volume. Now, volume have different components. You have objects, which are prisms, and objects that have a cross section. And we spoke about what cross section mean. If you turn this to the side and cut it, you will see the same shape that you see on the edge. That's what you call a shape with a cross section. Everybody with me? So if I was to cut this, I can see the same face. If I cut this, I can see the same face. It is consistent along the length of the body. So if you got it, you got it. Because this is standard for most 3D shapes that are like this. And we're going to look at the exceptions, okay? So anytime you need to find the volume, what do? Find the area of the cross section. This has happened a lot. And then you multiply it by the length of the shape. How long the shape is. If it's standing up, you know it's the height. If it's lying down, it's the length. There's no difference between it. Sometimes it's the height if it's standing up. Sometimes it's the length if it's laying down. Everybody see the difference? But it's the same thing, right or wrong? It's just based on how it's positioned. So it's always the area of the face times the height or the length, whichever one based on the position of the shape. That's volume for you for these type of shapes. Area of the cross section times h. Now let's do surface area. This is a bit more tricky. Or this was an example of a shape that does not have consistent cross section. So a cone, you could never use this formula to find the area of a cone. Everybody with me? It's a completely different situation. And this formula comes on the exam, the area and the volume of a cone. So don't stress yourself. All right. So let's look at surface area. What is the difference between area and surface area? Area is when you have a 2D shape. So that means you just have one face. So you know it's a length times a width. Surface area is when you have a 3D shape. What does that mean? So let me erase all of this mumbo jumbo here. It means then that you have different sides to account for. What are the sides that we're looking at? Front. Everybody see the front? And then you're going to end up with what? Ain't got back to this. The shape ain't got back. I forgive me because, you know, I just struggle with this thing here. I think I did not so bad, right? Everybody seeing it now? So we got front, we got back, we have a left, we got a right, and we have a top and we have a bottom. How many faces is that? 6 faces. I have a question. How many vertices does this shape have? Everybody, make a guess. Even if you don't know, make a guess. Excellent. Vertices mean corners or points of connection. This would be 1, this would be 2, this would be 3, this would be 4, this would be 5, this would be 6, this would be 7, this would be 8. So that's 8 vertices. How many edges? All right, so let's count. Edges are the lines. The lines. So let's see how much edges we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Excellent job, everybody. 12 edges. Okay, sometimes they ask questions like that, so I needed to make sure, okay? All right, so let's go into the actual surface area. Now, be honest. How many people think they could handle a surface area question? Somebody said, find the surface area of this shape. Would you be able to do so? Yes or no? All right, no problem. So I'm going to take my time and go through this. So what I want you to know, the surface area is you finding all of the areas of all of the faces and adding them up, right? When you look at a shape like this, the first thing you have to ask yourself is, what type of faces do I have? If you look at it, all of them look like what? Rectangles or squares, but let's call it rectangles because we don't know if the sides are the same. Agree or disagree? So essentially, I know I need to add up 6 sides because I got 6 faces. But to make work easier, do I have to find each face individually? What we should know is that the front is going to match the back, right? So front and back equal. So if you find the front, you just got to do what? Find the front and multiply by 2. Everybody with me? Then same thing, left and right are equal. So you find the left and you multiply by 2. And same thing, top and bottom, you find the top and you multiply by 2. And when you add them all up, that will give you the total surface area, because then you have the area of all of the surface. The front, the back, the top, the bottom, the left and the right. Everybody understand that concept? Talk to me, talk to me. Only Gwen is 16 people in here. Only Gwen's answering and letting me know that she with me. So we're going to look at a worked example. It's already done because it would take too much time for us to do it from scratch. So we're just going to follow what was done previously and just make sure we understand it. So it had some numbers here. Let me see if I could get them back. Can I get them back? Can I get them back? That's the numbers. Okay, it looks like that's the numbers. Yes. All right, so let's go. Find the total surface area of this cuboid. And we should know what makes a cuboid. A rectangle makes a cuboid. And what does a square make? What 3D shape a square make? A cube. Okay? For a cube, do we have to do all our work to find the surface area? All the faces wouldn't be alike. All 6 faces wouldn't be alike. So for a square, it's very easy. You find the area, length times width of 1, and you multiply it by 6 because all of them are equal. Everybody with me? So let's get back to the cuboid. So when you look at these dimensions, I think I did not give all. I think I gave these 3. So this is how it's going to come. They're going to give you 1 length, 1 width, 1 height. Everybody see that? So you have to figure out, if you want the front, what 2 dimension, because you know it's length times width for all the faces. What would be the front? What 2 numbers would be the front? Myrtle says 10 and 5. Do we agree? Look at what lines make the front. If you look at the lines that make the front, check it out. Because that's that students just get this mixed up all the time. So this is your front. What do you need for the front? You need the length and the height, right or wrong? So you know this is 10, and if here is 5, that means here it's 5. So that's 10 times 5. Everybody see that? What we gonna need for the top? So front is 10 and 5. What is the top? What's the dimension for the top? Let me see who's thinking. Jerome said 10 and 3. Anybody else? What is the top? Everybody see why it's 10 and 3? Because this, if down there is 10, there is 10. And to get the top, I need these two lines. And if this is 3, this is 3. Excellent. So what would be the right? What's the dimensions for the right? What's the dimensions for the right? 5 and 3. Excellent. Excellent, excellent, excellent. So let's go over to the workings. So if you want the total surface area, look at what you got to find. You find the front. 10 times 5 is 50. So the front and the back is 50 times 2. Everybody see that? So this is the front and the back. You want the left. We said the left is 3 and 5. So that's 3 times 5, 15. So the left and the right is 30. The top is 10 and 3. So that's 10 times 3, that's 30. So the top and the bottom is 60. And so the total surface area would be what? When we add all 3 or all 6 together. Everybody understand? And this is what we did here. The 100 plus the 30 plus the 60. So question, if you get a cuboid, should you be able to handle it now? I'm going to give you another one. I'm going to give you a triangular prism. Let me see if they give you the triangle. Oh, they give you the triangular prism. So we don't have to go through it. No, I remember going through this. The total surface area for a cylinder is very different. We know the volume is easy. How is it this? How do we know this is the formula for volume? Because we know pi r squared is the area of a circle, right? Times h. The face of this 3D shape in a circle. So then we say the area, volume of any shape like this. You find the area of this cross section and then you multiply it by the height. That's what it did here. That's why it's pi r squared, which is the area of a circle times height. That easy. Curved area 2 pi r h. How they get that? What does 2 pi r represent? This in the circumference. Talk to me. This in the circumference. Times h. So let's look at this now. What do they mean? If I was, let's think about this like a toilet tissue roll. What the brown thing call it? What the brown thing inside the toilet paper call? What do you call it? The roll, what do you call it? I know what I'm talking about, right? Just the roll, right? The brown roll thing. Okay, the roll. If you ever cut that roll and open it up, anybody realize that the shape is a rectangle? Take a white piece of paper and roll it into a cylinder. You'd realize that's the shape of a cylinder. Everybody with me? If you need to do it yourself, do it yourself. Get a random rectangle paper, roll it over, roll it this way, connect these two sides to each other. You realize you get a cylinder. Okay? So what they're saying, if you want to find the area of the curved shape, you open it out. And what shape is that? Length times width. But we know the width is the height. But what is this distance here? We can't really call it the length. When you look at it, isn't this the circumference of the circle? Look at it. Because all we did was cut it open here and spread it out. But when we roll it back up, isn't this the circumference of the circle? So that is why the formula is 2 pi r, which is the circumference, times h, which is the height. This don't come on top of the exam paper. So you definitely need to remember that. Total surface area is easy. You find this section here, which is what you found here, and you add 2 circles because you have a circle to the top and a circle to the bottom. They don't ever bring a sphere. And if they do, the formula is on the formula sheet. So you don't have to remember it. You just got to substitute. What is the only two things you're substituting? Pi, which is 3.142, and R, which is whatever radius they give you. Everybody see that? These two are given on your formula sheet. I'm going to back check and make sure. All right, so that's it for surface area on these elements. We almost done. We have what we see here, or what? Triangular prism is the same formula like everything else. Find the area of the face, multiply it by the length. Half base times height, which is the area of the face times the length. Total surface area is different though. You have to find the sum of all the faces. How many triangle faces this shape has? Serious question. How many triangular faces does this shape have? Without me drawing the back, what happening in the back? Measurements, to me, I hate measurement, but we just gotta get it done and we just gotta try and master it. We could do this, we got this. So Myrta says 5 triangles. Anybody else? Guess what, guys? All of you are wrong. All of you are wrong. It's just 2. It's literally just 2. Guess what the triangle is? The triangle to the front, or should I use a different color? Sorry, I should have used black. The triangle is only to the front and the back. Everybody seen it? So you have the face and the back. But all the other shapes are what? In rectangles. So you're ending up with 2 triangles plus 3 rectangles. Tell me if you've seen the rectangles. Let me erase the... Y'all seen the rectangles? The base is a rectangle. They got a rectangle in the back here, and they got a rectangle on the top here. Yeah? So that's all. And you know how to get your measurements, because if you got B, you know which side you gotta use half base times height. You got A, which is the length here. You should be able to figure out which side is which side to find the area of the rectangles. You know how to find the area of a triangle. You just add them up, okay? Done with that. Done with that. All right, so rest of these questions are just practice questions. So I'm gonna leave these here and we're going straight into exam mode. The only difference is, do y'all know how to change 24 hours to 12 hours? So if I say it is 1600 hours, what time this is? Everybody know how Myrtle got 4 p.m.? Subtract 12. Easy stuff. We did scales as well. We did scales as well. Anybody know the conversion cloud? This does not come in the exam. When you're drawing the conversion cloud, you need to remember this. You always start off with the smallest measurement, which is what? Millimeters, right? What's after millimeters? Centimeters. Then what? Meters. Then kilometers. Then you got your arrows. To move from K, what does kilometers, what does kilo mean again? Kilo means 1,000. So you have to multiply by 1,000. The next one, where you're multiplying by 100, multiply by 10. The opposite way is the opposite operation. So divide by 10, divide by 100, divide by 1,000. These are things you need to know in the back of your head. Okay? There's also something with centimeters cube and liters. I think I went through it. Let me see if I could find it. Hold on, Leon. So let me just take a minute to show you this. Speed, they're gonna always give you the units. Let me go back here. They can always give you the speed for units. They're gonna say, look at here, look at the formula. Speed is equal to distance divided by or over time. Everybody see that? So let me write it over here and I'm gonna ask some questions. So speed is equal to distance over time. Guess what my first question is? What's the formula for time? What do you do to find time? How do you transpose this to find time? This is algebra again, eh? It's one step. Nope. Switch. Remember time, the thing that you want in the denominator. When the thing that you want is in the denominator, you just switch it with this here. So time would take its place. So it would become distance is equal to, time is equal to distance over speed. Now, what's the formula for distance? If you want, you start off with the original formula. How do I get distance alone? That's where you multiply by what? To get rid of time, you multiply by time on both sides, right? Because this and this gonna do what? Cancel. And so distance is equal to speed times time. You know what I'm teaching you? I'm not teaching you to memorize, you know. You see how I just need to know one, and then once you know how to transpose, you know how to find the others. Everybody see what I'm trying to show you? So what's the formula you actually do need to memorize? Speed is equal to distance over time. I can find time, I can find distance by transposing. If I want t, I switch it. T is equal to distance over speed. If I want distance, I get rid of the t by transposing, getting rid of it. So d is equal to s times t. Okay, math skills. All right, so let's get into the past paper exams. And then what time it is? How much time we got? We got half an hour. And then we're gonna be done. So hold on there. So these are the questions we did already. For those asking, we did these questions already when it comes to volume. So I'm not going over again. If you need to see how we work it out, just go on the Google Classroom and look for past paper measurements. We did those three. This is the one I want to do now. I think I'll do this one. We got enough time to do this one. And that's where we can stop. I think I want to do this one too. This is the last one. So this one with the water and this one here. All right, so let's go. We're not calculating, we read and train, we're making sure we understand. So first one, the scale on a map is 1 to 25,000. But before I start, y'all ready? If you're ready, say ready, 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 ready. It's better that we push today than we trying to push the night before. So that's why I'm willing to go all out Sunday, try to recap as much Sunday so that Tuesday night is just light things like paper one stuff and just recapping short things, nothing so heavy like today. All right, so we have scales. So they tell us 1 represents 25,000. So let's go. So what does this mean? It means 1 unit on the map represents 25,000 in real life. That's what I really mean. So if they give you a measurement on the map, you should be able to calculate what the actual distance is in real life. So it says, determine the actual distance in km represented by 0.05 meters. How do you do that? We did this in ratio. Look at this. If 1 is this 25,000. How do I move to 0.05, 0.5? If I multiply 1 by 0.5, what am I going to end up with in 0.5? Remember, that's always the key. Once you know 1, you know any number, right or wrong. So if they had asked for 2, what we would have done, we would have multiplied by 2. So if they want 0.5, you multiply by what? 0.5. Whatever you do to one side, you do to the other side, right or wrong? Look at here. That's the answer. But what did they ask for in real life? What they asked for? They asked for your answer in what? Kilometers. In km. And what did they give us? They gave us cm. How do we find out? How do we know that it's all of this? Remember the conversion cloud? You multiply it. So you do it again. Do not be afraid to do this in the exam. If you don't remember, it is better to do this than getting it wrong. How do I move from km to cm? So from here to here is times 1,000. And then from here to here is 100. So in total, to move from here all the way to here, how much is that? Wouldn't that be 100 times 1,000? Why do I have 4 zeros if it's 1,000? Sorry about that. But everybody see what I'm trying to show you? So 1 km is actually equal to what? 1,000 times 100. So you add 2 more zeros. So that's 100,000. I'm going to stop right here. Everybody see that? Because there's no way you would know this out your head. You have to work it out. If you got it, say got it. I know a lot of people get baffled. They don't understand how to make these connections. You have to use these basic things. Nobody expects you to memorize this. When I say memorize this, memorize these units, you cannot. So what you need to memorize is your conversion table. From your conversion table, you do your own conversion and you figure it out. I want to move from km to cm. I got to calculate it using my measurement conversion table. So that's that. So let me zoom back in here. So first thing first, everybody understand how we got the first answer? But the answer was in what? cm. They specifically said they want the answer in what? km. So we know based on our conversion, 1 km is 1,000 cm. So guess what we got to do? And guess what some people is make a mistake doing? They just multiply instead of divide. Why do you think you need to divide and not multiply? What do you think could help you do that? What are you moving from? If you are moving from cm to km, look at what happening to the numbers. You're moving from a bigger number to a smaller number. So what does that tell you need to do? And divide. Everybody understand what I'm trying to show you? If you were at km and they asked for cm, you would realize you're moving from 1 to a big. So then you know you have to do what? Multiply. So anytime you forget what to do, look at your units. Once you get your units, which is 1 km is equal to this cm, you look at who you're moving from, who to who. If you're moving from cm to km, you know you're getting smaller in value, so you divide. I hope I'm making sense and I hope I'm making it clear what to do and how to do it. So that's what they did here. Look at it. Look at what they did. So they take this number. To me, they're doing a lot of drama because all they needed to do was take this 12,500 and divide it by this number here, right or wrong? But this is exactly what I mean. Multiplying by this is the same thing as dividing by it. So once you do that, you get your answer. Represented as a decimal is the easiest way. So let's get checking. Everybody with me? Because if they bring a question like this, you should be able to mash it up. The first thing you should be thinking is scales. Let's go. We got 16 people in here. Just confirm if you're with me. Because this question was so easy. You're literally just moving from centimeters to kilometers. So you're really multiplying and dividing by some basic numbers. Okay. All right. This is the real thing now. This is the real thing now. Oh, we got one more. Calculate the actual area in kilometers square. So I would underline this because I circle it because this needs to remind me that I have to make sure my answers is in kilometers square. Look at what they do. You see the thing I tell our editors do? You realize they're going to give us something in centimeters, but then ask, you realize I tell at the beginning, that's really all you're doing in measurement, moving from one unit to a next unit. Hello. All right. So they gave us this. So what we got to go back to, we ain't got to go back to the scale. 1 centimeters on the map represent this amount in real life. All of this is in centimeters, eh? So 1 centimeters on the map represent this amount of centimeters in real life. And they gave us a certain amount. So I will go back and write back my scale. So 1 centimeters in real on the map represents 2, 5. How much zeros? 3? 3 zeros. I always write back the things I need. Good. But guess what? Is this regular centimeters or centimeters square? Good. So let's look at what we have here. What they did, I wonder why they did this. Oh, I see what they did there. They did the area conversion. So just like how we started off with this, we need to convert it one time. So we know why we have to divide by this number. Everybody remember why we're doing this? So they're converting it again one more time. So let's go through step by step. And every time I ask you, you need to let me know if you understand. So step 1, convert it just like what we do in the beginning, we convert it again. 1 cm is equal to how much km? And in fraction form, what would this be? This would be what, 0.25? If you want to use the decimal version, that's okay. So confirm if you understand this first part. So they did the conversion from early. All right, now this is different because what does km square mean? Km square A mean km times km. Cm square A mean cm times cm. So you realize we're dealing with a different unit. So we have to find the km square and the cm square. So that's what they did. So look at that. 1 cm times 1 cm is 1 cm square. Agree or disagree? So it's the same thing by saying, but I would have used the decimal version, to be honest. So I would have used 0.25 times 0.25. What is that as a decimal? Oh, that's it here, 2.25. Somebody check with your calculator for me. 0.25 times 0. A quarter of a quarter is not that. What's a quarter of a quarter? You're supposed to get 0.0 something something. So you will get 0.0625 km square. So 1 cm square is actually equal to 0.0625 km square. Anybody checked it with your calculator yet? So this is what we're gonna need, because this is our basis for our conversion now. Now we have the units that we want. We have the cm square to the km square. You realize we ain't gonna calculate nothing yet because we cannot calculate what we do not have. So we have to find this conversion first. Now, what did they give us? They gave us 2.25. So I'm just gonna come here and write it out and show you. It's just like ratio. If I have 1 centimeter square is equal to 0.0625 km square, how do we find out how to get 2.25? What did I do to 1 to get 2.25? A multiply by 2.25. So whatever you do to one side, you do to the other side. Everybody see the connection? So this is equal to 0.0625 times 2.25. Tell me how much I get, please. Somebody work that out for me. Oh, look at here. Same thing. Tell me how much I get. Tell me if we get this to the bottom here. Look at that. No, let's be real. The way they do it here ain't confusing the way they do it here. That's why I just teach my own way, you know. Because why would anybody want to use fractions? So tell me which way y'all prefer, the decimal way or the fraction way? Because if y'all prefer the fraction way, that's okay too. So everybody talk to me, which one you prefer, decimal or fraction? You prefer the fraction way? Okay. Decimal. All right, so that's it. That was it. The only difference is before we could apply the conversion, we had to find the centimeter square before we get into actually calculating the other stuff. All right, so this is the part I really want us to get into whenever they got stuff like this. So let's go. The diagram not drawn to scale shows a cross section of 2 cylindrical jars, jar X and jar Y. The diameters of jar X and jar Y are 3D and D respectively. So from the jump, I know that this is 3 times as much as this, or that's what they claim. Everybody see that? Somebody calling me. You can't answer. All right, so let's get into the question. Initially, jar Y is empty and jar X contain water to a height depth of 4 centimeters. Determine in terms of pi and d the volume of the water in jar X. Be honest, anybody here know what to do? No, this is the first concept I want to explain. Even though we are seeing a shape of a square, a rectangle, what is really the shape of this object here? What is the base of the shape? What is the shape of the base? In a cylinder, they say. Talk to me. So what is the shape of the face? What is the base? You know, you got a base. What is the shape of the base? We got to be able to figure this out. If you have a cup of water, a glass, when you look above and look down in the cup, what shape you seeing? Is it really oval or is it circular? It's a circle. Everybody with me? This is why students fail this question, because I'm gonna be honest with you, it's so confusing. Because you realize in this picture, they don't show you nothing about no circle. They expect you to know that cup, and they told you, what shape did they tell you above? What words you need to underline? Cylindrical. What cylinder mean? That's how it really is, right or wrong? You see the connections y'all need to make? Even though the diagram look like this, what it really is in this. And don't we know how to find the volume of a cylinder? What is the volume of a cylinder? The area of what? The cross section times what? The height. Agree or disagree? What is the area of a circle? Pi r square. So this is the formula we're really going to be substituting for, right or wrong? So this is what I want to focus on. You realize how they took something as basic as this and make it look difficult. You cannot let them beat you like that. You got to think. The first thing I want you to do is when you're in an exam with this question, when you see the shape, read it and imagine what shapes you're going to. You see how I draw this here? Draw the shape here to remind you what you're really looking at. Everybody understand me? You cannot just look at this and expect to figure it out. You're gonna be lost because first thing you'll be thinking, oh man, this is a rectangle, but why they tell me pi? What pi got to do with this? You got to remember what cylindrical mean. They literally tell you, and look at the clues. Look at the clues. Cross section. What I mean, you need to remember what shape the cross section is, and they're telling you it's a cylinder. So what shape you should be looking for? A circle. What should be coming to your mind then? Pi r square. And the formula on the sheet. This formula is on the sheet. I don't take the one for the volume. Volume is not on the sheet. Area is on the sheet, but volume is not on the sheet. So guess what you gotta remember? The volume is equal to the area of the cross section. That's the face, wherever the face is, times the height. And you should know the face is a circle. That's pi r square. Everybody with me? Everybody understand a little better now? Okay. They say determine the volume in terms of pi and d. Do you know what I mean? Your answer must go in pi and your answer must go in d. They didn't give us a value for d, so we just got to substitute it in the formula. So what do you start off with? Let's go up here and look at how they write it out. You realize this? Look at this. Then what they start off with? Volume is pi r squared times h. Talk to me. And you know, R stands for radius and H stands for height. So I'm going to do it myself because that looks confusing. I mean, trying to stress out. So let's start from scratch. Volume is equal to pi r squared times H. Now, which number we have? What number they give us? Don't we have H? What is H? Everybody agree or disagree? Is it 4? Yeah, man, look at here. Height is 4. So we substitute that. Do we need to substitute for pi? No, because they tell you they want pi. When somebody tell you in terms of, just like in vectors, when they say write what this is in terms of A and B or M and N, they expect you to use it in your answer. Agree or disagree? So you put back, I don't know why I put H here when it's supposed to be 4. So you put back pi. The only thing we need to focus now on is what? In R. What is R? No. Let's go back to this diagram. What does 3D represent? Let me see if anybody thinking. What does 3D represent here, this picture? Excellent. That's the diameter, because remember the circle. So if we're going from one end to the next end, this distance is the diameter. But do we need the diameter? No, we need what? In the radius. How do we change the diameter into a radius? We spoke about it earlier. What should we do to change the diameter into a radius? Excellent. You divide by 2. So you realize they want the answer in terms of D. So what is R? R is what? 3D, which is the diameter, divided by 2. Agree or disagree? So let's go back now. So the next step would be what? We know that pi stays. We know that R, we put a bracket. And why should I put a bracket? Because I got to square R. And R is a bunch of drama. All of this is R. So I got to put 3D over 2 in brackets what? Square times 4. Everybody see that? So what am I going to end up with? I know how to multiply in algebra. Anything times 4, you just put 4 in front. So 4 pi 3d over 2 square. And we could break this down. Everybody see what I did here? You realize they expanded? Now they made a mistake because look at here, they got 3D. Oh, I know what they do. They multiply the 4 by the thing and divide it by 2. So there we go. Let's work it out like what they do here too. So what we're gonna end up with? We're gonna end up with 4 pi. So before I continue, everybody see how I reach here before we break it down? Because breaking it down is really algebra. So there we go, 4 pi. If I square this, you know, you gotta square the top and the bottom, right? So 3d times 3d is what? 9d square over what? A 4. Anything here could cancel. Let me see if I'm thinking. What could cancel? These 4s can't cancel. Because this means 4 times pi times this. So once you multiply by 4, you could cancel that. So what is our final answer? 9 pi d square. You realize from here, the only part that was kind of challenging was from here to here. You realize from here to here is algebra. Tell me if you're seeing it. You realize that's what happening with every single thing. You use the concept of the topic to get you started, but to finish, you have to use algebra. If your algebra skills are weak, this part you're gonna get stuck. So let's see. Look at here, 9 pi d square. Yeah? Talk to me, talk to me, talk to me. Sorry, look the answer up here, sorry. Was it easier to follow the way I broke it down? Talk to me. So step 1, everybody, make sense of the diagram. Use your sense. Think about it like in real life. If they tell you, they're giving you, suppose like they tell you they give you a triangular prism. You know when you look down in that cup, the cup gonna show you what shape is at the bottom of that cup. It's gonna be a triangle. And so you know you have to take the triangular approach. You're supposed to be then using what? Half base times the height times the height. If they're giving you a shape which would have been a cuboid or cube, you know, that's length times width. Trust yourself and your instincts and think about it like you do looking at it in real life. If you do not do that, you will never figure it out, because the truth is none of this is beyond your understanding. All right, so let's keep it moving. So we understand how to apply our approach to get here. Next one. If all the water from jar X is now poured into jar Y, calculate the height it will reach. Now, what do we realize? The only difference between the two containers is what? The difference in the D, right? Right or wrong? Because the shape is still what? The shape is still cylindrical. That's the only thing that's different now. D is different. And if D is different, R is different. So what do? Did the water volume change? So if we found the volume to be this, what must happen? Wouldn't this be the same volume in here? So the only thing that can change is what? The height. So guess what you got to do? Take the answer that you found, find your new volume and put them together and solve. What do I mean by solve? You cancel until you find, you make H the subject of the formula. Everybody realize what I mean? We have our first equation here. Just like what we did here for the first container, essentially, you do it for the second container. So you see how we found this? We substitute until we found this. You do the same thing. Y'all want me to do it so you can see? All right, so let's do it. Again, we know volume is what? Start with the basics. Volume is cross-section area of the cross-section times the height. What is the shape of the cross-section again? It's a circle, right? So we know that's what? Pi r squared times h. H we don't know, so we can't substitute. But we know pi stays the same, and we know r gonna be half of d. And you realize it's d. So you see r is equal to d divided by 2. So r squared is brackets d over 2 squared times h. Tell me if you're following me so long. So we expand pi d squared over 4, because after we square this term, times h. Now, you know, in algebra, when you're multiplying two variables, what do you do? Join them up. So you're going to end up with pi d squared h over 4. So everybody see how we get the formula for the second container? No. Did the volume of the water change? No. So V1, let's call up here V1. The first thing we find as V1. And this one that we found for the second container, let's call it V2. If we just pour it over, it's assuming that none gets spilled. V1 ain't equal to V2. Everybody see the common sense here? That's the common sense part coming in, because they ain't tell you none of this. You just have to know that that's what's going on. You have to know that's what's going on. So all I did here, so we should now understand how we reach here. Because this is V1 and this is V2. And guess what they did here now? They cancel. So let's go. Let's do this together. Let's do this together. Let's do this together. So I'm going to do some algebra because I know we're struggling, eh? I know. Pi d squared h over 4. Who is the easiest thing to cancel here? First thing I would do is try if I want h. Remember we want h, eh? So who should I get rid of first? A in this 4. So let's multiply by 4 on both sides. So this and this is going to cancel. So you end up with 36 pi d squared is equal to pi d squared h. Who else do I need to get rid of if I want h? Main should get rid of all of this. I could divide by this thing one time. But what's going to happen? This and this cancel. This and this cancel. Check this now. This and this cancel. This and this cancel. So we're left back h and 36. What is this? Isn't this algebra? So h is equal to 36 centimeters. This ain't algebra. Because we done it. We ain't going to no more questions. This ain't algebra. So again, what do we realize is the hardest part of measurement in the real life applications? Because if you notice, these formulas and things here in the hard part is making sure you understand what to do with the formulas. So what I want to encourage you to do, to be honest, in your own time, go through fastpass.com and just read through the questions, because what that will do, it would strengthen your understanding of how to look at the questions. Everybody with me? If on Monday y'all want me to go through measurements again, like do another question on measurements, I will, I can. But I hope that this session kind of open your eyes to how to look at the questions. All right, let me see. That's the last part, and that's it. That's literally it. So in this exam, what they did, they gave you a conversion through using the mappings, the scales, and if they don't give you that, they're gonna always give you something with speed. So be prepared for the speed question, and we know the formula. Speed is equal to distance over time. If they ask you to find the time, you know how to switch it. If they ask you to find distance, you know how to transpose. So how you are feeling now that you see how you should be thinking? 7. Come on, everybody, talk to me, talk to me. I know this is a lot of revision for one session, but we have to. Let me go through, see if anything else. And look here, everything else is the same. The only difference is you see, you hear they ask you to use pi as 22/7. You got your calculator. You should be able to do that. Or they sometimes give you density. So I'm glad that we saw this. This is another formula that you need. Density is mass over volume. I think everybody should write this down. But this is easy. It's the same, transposing. If you want to find the volume, what do? You switch with the density. If you want to find mass, what do? You multiply by volume on both sides to eliminate. This formula does not come on the exam. You need to know it. Neither does speed. Oh, let me see. This is the same concept. If you want to find the volume of this, you just got to find the area of this face. Let me see. This is more so like a geometry, it looks like. This is something I want us to go through quickly. Y'all know, but this is geometry. You see how they bring measurement in geometry? Is this a geometry question or a measurement question? It's a measurement question, but you got in geometry. Wow. Some of the interior angle of a polygon is that. All right, so guys, I have to do something. So is it okay if we push the second session to 4 o'clock so we could get an hour break, a full hour? It's 2:30, so we got an hour and a half. Is 4 p.m. okay? Because we need to just mentally reset. And geometry is very heavy. So that's what we're going to do. So we're going to be back for 4 o'clock. What I'll do in the meantime is try to prepare the PDF with the measurement formulas and send them to you so you could have them. And at the end of the formulas, you will see some examples, some worked examples as well, okay? So that's where we're gonna stop now until 4 p.m. I'll send a message when I'm ready to start, okay? So see you guys at 4, no problem. So I'm gonna download this video as well and upload it. So see you guys that time.